Hello, welcome back to Iver Environment Centre. This week we're going to be thinking about food chains. Food chains is something that we've mentioned in passing in previous sessions, but we're really going to start thinking about the flow of energy through a food chain today. So a food chain thinks about the feeding relationship, so what eats what and where the energy comes from and goes to. Now, no energy can be made, so all food chains use the energy that comes as light from the sun. But we can't turn sunlight into food. What can? That's right, plants do. They use their green leaves to turn light energy into food with the help of water and air. So we call them producers. Producers is just one of the key words we're going to be using today. Shall we say it together? Producer. And so if a plant that produces food in its leaves is the producer, what do you think we call the animals that eat the plant? Or the animals that eat the animals that eat the plant? Well done, a couple of you got that. Consumers, yes. That's another key word. Producers and consumers. We have some other words that we will be using today, and I think these are words that you're probably more familiar with because we've used them before in previous sessions. One of our words is herbivore. What's a herbivore? Of course, it's an animal like this bunny rabbit that eats plants. So the next one is an animal that eats meat, like this hedgehog that loves to eat all sorts of worms and other grubs. That's right, that's a carnivore. They're not all big like tigers, are they? And then we have our omnivores. I'm going to move this into the sun a bit. It's in shadow. Like this badger who likes to eat some berries and nuts and seeds, but also loves to eat earthworms. We also have some other key words that I'd like you to be using today. So an animal that eats another animal, like this hedgehog, is not only a carnivore, but we can also call it a predator. So this animal is a predator. The thing that it eats, we call its prey. So for a hedgehog, the prey might be something like a worm. So what's this animal? Is it a predator or is it prey? That's right, it's prey. This rabbit is prey, and the predator for this rabbit would probably be this fox. And all of these predators and prey are adapted to their role, and you can see in their bodies the different adaptations that make them more successful. Now I'm going to show you some pictures of skulls. None of these skull pictures belong to me. I just got them off the internet to show you what I wanted to tell you. So this is a sheep, which is a herbivore, and it's also a prey. It gets eaten by wolves and things, and us. We're omnivores. And you can see that as a prey species, its eyes are on the side of its head, meaning that it can see to the front and to the back. With two eyes on the side of the head, you can see almost all the way round. You also might notice that it's got a very big bit of bone here. Now this is the attachment for what we call the masseter muscle, the muscle that you use for chewing. That's my sheep impression. Can you see how the master muscle helps it to chew from side to side? Us humans aren't very good at that. They've also got teeth made for grinding. They've got a space here to move the food around, and then their teeth are made for grinding up food against each other. And if you look closely at the teeth, you'll see that they've got lots of little ridges to help grind up the grass and other plants even better. A predator, on the other hand, like this fox, looks very different. Its teeth have got sharp fangs at the front for grabbing and tearing their prey. And then at the back, the teeth aren't ridged, they're pointy, and they work like scissors, slicing up the meat for them to eat. If you look at the skull from this point of view, you'll notice that the eyes are at the front of the face, and that helps them to judge distances better so they can pounce on their prey. You can see how important both your eyes are for judging distances by this quick simple test. Put your finger out in front of you like that. Close one eye and use your other hand to try touch your finger. It's quite tricky, isn't it? Open both eyes, you can do it no problem. But if you close one eye, you need to concentrate a bit harder. They probably use these little teeth at the front as a bit of a comb. Another thing you might notice is that on the top, it's got what we call a temporal ridge. It's got a little crest on the top of the skull. That crest is to attach your temporal muscles that help you when you're biting down really hard on something. To test that, I'd like you to put your fingers on your temples and chomp down with your teeth really hard. Make sure your tongue's not in between them, that would hurt. Can you feel the muscle moving there? Well, that's the muscle that's attached at the top of the head, and that's why predators like foxes, like tigers, have such a big crest to attach that muscle to them. And it's the same with birds. Can you see how in this picture of a kestrel, taken by someone called Louise Morris, just found it on the internet, he's got a very curved top part of its beak. And again, that's for tearing and ripping the flesh of the animals that they eat, the birds that they've eaten. On the other hand, if you take a herbivore, like this goldfinch, it's got a very short, pointy beak. And that beak can be used a little bit like tweezers to pick up seeds and nuts, and it's short and fat, so it's nice and strong to break any nuts that they need to. And it's not just big animals that have these adaptations. Perhaps the most spectacular predator adaptation of all comes from spiders. Tiny little spiders that can weave these huge webs to catch their prey. Or maybe it's this dragonfly with its long front legs that can catch its prey mid-air. So when we're writing food chains, we always start with the producer. Not the best picture, but there's our producer. We then go to the first consumer. So what might eat this flower? Maybe a caterpillar. And we call that the primary consumer because it's the first consumer. And then we have the thing that eats the caterpillar. Maybe it's a bird. I'm not great at drawing. And we call that the secondary consumer. Now we never say the bird eats the caterpillar which eats the flower, because that would be going back in time. We always think about how the energy, the food, is flowing through the chain. And we start with the producer. So the flower is eaten by the caterpillar, which is eaten by the bird. Let's give that bird a wing. Does that make sense? So now I'm going to ask you guys to do your own food chains. Time for your challenge. Grab your pencil and your paper. To make it a bit more challenging for you guys, I've got 2 food chains here for you to sort out. So we have this producer, the pondweed. We also have a sycamore leaf. We've got a tiny little water flea in here that stopped moving. Oh, there it is. Can you see it? Moving about? Not very clearly. But there's the water flea. We've also got a shrew. Can you see its long nose and all those hairs for it to feel things moving? Those whiskers, they're very sensitive. We've got a damselfly larvae. We've got a worm. And we've got a fox. Okay, off you go now. See if you can put them into the right order. Remember, each food chain will start with a producer. So perhaps get the pondweed and the sycamore leaf out first, and then think about what might be consumers of them. If you need a bit more time, feel free to pause the video if you're not watching this live. Right, let's go through the answers and see how well you did. So I'm going to start with the water food chain, the pond food chain, and of course we start with the pondweed, with the plant. It's great to have plants in the pond because they give lots of oxygen into the water for the animals that live there. So we'd have our producer there, and then we do an arrow towards our primary consumer. And so the consumer is the water flea. That water flea then goes into the tummy of our damselfly larvae. And if you look closely at the damselfly larvae, you'll see that its front legs are nice and long for grabbing prey. That's an adaptation, as is its strong tail for swimming quickly after them. Right, let's try our other food chain. So this one starts with a leaf. This one's from a sycamore tree, and the leaf would fall off the tree and get eaten by a worm. That would be the primary consumer. And then the worm gets found by the shrew. Its long nose would root around in the earth to try find it, using those sensitive whiskers to feel any movement. But hang on, we didn't just have 3 in this food chain. we had 4. So we had a primary consumer, a secondary consumer, and a tertiary consumer. Don't worry, you're not expected to remember all of these until you're a little bit older. So this is a herbivore. It's prey to this carnivore predator shrew. But this is the top carnivore in this food chain because it's eating another carnivore. Now, we can start with food chains, but we can also turn these food chains into food webs. Because it's not just worms that eat leaves. A caterpillar would, wouldn't it? So the leaf could also go into the caterpillar's belly. They also get eaten quite a lot by aphids. Aphids are those bugs that you'll find on leaves. Some of them have very long antennae, and they're insects, so of course they have 6 legs, 3 on each side. Let's do a nice happy aphid there. Now, aphids get eaten a lot by ladybirds. Ladybirds love aphids. In fact, sometimes people release ladybirds as a natural pesticide to keep the number of aphids down, because if you have too many aphids, they eat all your roses. The ladybird would then get eaten by another bird, maybe a blue tit. And again, you get my wonderful attempt at a bird drawing. But that bird might get eaten by a even bigger carnivore, a top carnivore like this kestrel. Isn't that a long food chain? The producer with the leaf, then an aphid, then a ladybird, then a blue tit, then a kestrel. And that caterpillar would also get eaten by the blue tit. And that worm might also be eaten by a badger. And so you can see how the food chains can join together to make a food web. And that shrew would probably chomp on a few ladybirds, so those would end up, lots of beetles might end up in the shrew's tummy. And so we call this a food web because it reminds us of the spider's web that we looked at earlier. And everything in this food web is balanced. They're all connected to each other. So if you do something to it, if you remove something from this food web, it will have effects on all of the other animals in the food web. So for example, if I removed the ladybird, used a pesticide that made ladybirds go extinct, what would that do to the aphid? Well, there wouldn't be the ladybirds eating the aphids, so the numbers of aphids would go up. What would that mean for the plant? Well, that would be bad news for the plant because the aphids, there's so many more of them and they're all chomping on the plant. That might not survive till next year. And if the blue tit didn't have the ladybirds to eat, it might eat more caterpillars, and the number of caterpillars might go down. And so we'd have fewer butterflies, which would be a real shame because butterflies pollinate the flowers when they're drinking the nectar. And so again, it's bad news for producers, for the plants. So when you next go for a walk and have a look outside, think about how everything is connected And what might happen if the tiny animal that you're looking at were to disappear because people didn't look after it? For tuning in again. So your challenge for this week is to make your very own food chain. You can make it out of junk modelling. I can picture in my head some really nice caterpillars made out of egg boxes. You might want to paint some stones or make it out of Play-Doh. I'm sure you've got lots of creative ideas of how you can represent the food chain. So remember, it always starts with the producer, and the arrows show the direction that the food, that the energy is going through the chain. I look forward to seeing what you come up with on this challenge. However, this will be our last Nature Live session on a Tuesday. Next week is the half-term holidays, and then after that we will be concentrating on how we can help support schools at this difficult time. I know so many of you will not be going back to school after half-term, and we will keep on putting resources up on our Facebook page for you to carry on exploring outside. If you are a school that has shared these sessions, like Stoke Clifford School, I've noticed has shared a few, please do contact us, see if there's any way that we can support you directly. There might be something we can work out. Thank you so much to everyone for taking part in these sessions. I've really enjoyed seeing everyone's comments, both during the videos and afterwards. Please keep in touch. On Thursday, I will be taking you on a tour of the centre to see how much it has grown since we started these sessions back in March. And I'll also be answering any questions you might have, so please do send me any questions you can think of. If you do it in advance, I'll definitely have them. Hopefully I'll have it set up on the day, but you know what I'm like with technology, it might not work. But yeah, I'll see you on Thursday for our final tour of the Nature Centre. Keep safe, and I look forward to seeing your food chains.